Good morning, everyone, and welcome to the webinar. So today we will be looking at the Civil Structures Series Part 3, which is basically going to talk about bridge design. So if you have a lot of bridge design workflows, issues, or challenges at the moment, this is the webinar you should be at. So thank you for joining. So I am Nadia Meinhardt, for those who don't know me. I am one of the BIM technical specialists here at Baker Baines. I mainly focus around training and support on Civil 3D, Revit, and Autodesk Construction Cloud. And I also recently obtained my ISO 19650 Information Management Practitioner badge. It's a whole mouthful, but that was one of them. So for those who don't know Baker Baines, I know a lot of you do already. I'm just going to do a quick introduction to Baker Baines. So Baker Baines mainly focus on three main areas. So as you can see there on the screen, consulting, education, software, and hardware. From a consulting perspective, we help businesses with BIM solutions, common data environments, and also helping them with their teams and processes. From a training side or education side, we are an Autodesk authorized training center, doing accredited classroom training as well as virtual training and customized or project-based training, and also self-paced e-learning with the help of Pinnacle. We are an Autodesk Gold partner providing software and hardware solutions, and we also work with leading partners such as your ClearEdge, OpenSpace, and Leica as well. And not only do we serve the building and civil industry, we also serve the energy, process plant, and manufacturing industries as well. So that's basically me and Baker Baines, but I have a great agenda for you today. So we are going to quickly just recap on the Civil Structure series. So there was 3 parts to it. So I will just quickly recap that. And then you all are here, obviously, for your bridge design workflows. So we're going to look at some challenges that you might be facing on those workflows at the moment, and then jump into the solutions to those challenges that you might be having. So we're first going to look at the different technology that you are going to use, and then the actual workflow. And then at the very end, I will have a live Q&A session. But if you do have any questions, please feel free to use the chat box or the Q&A box. My team is also here today, and they would love to answer some of your questions that you might have. Okay, so before I get started, I'm going to ask Anal to please launch the first poll. And I'm going to ask you, what is your biggest challenge in your bridge design workflows today? Is it managing design changes, coordinating between your different teams and disciplines, or maybe it's the generating of accurate quantities and costs? Or is it because you have a limited design automation or parametric options within your design workflow? Or is it because there's a lack of integration between the different tools that your teams or different disciplines are using? So I'm just going to leave that for a few minutes, and then I'm going to ask Anal to please read the results to us. Okay, Anal, do we have a few votes already?
Let's just give it a few more seconds. Alrighty, so Nadia, it looks like everything is very, very similar, but the biggest challenge is the lack of integration between tools, followed by limited design automation or parametric options, and then dropping off from there.
Okay, awesome. Thanks, Anal, for that. So I love the fact that the main one is lack of integration between tools, because the whole idea around this workflow that I'm going to show you guys today is how nicely the Autodesk tools integrate with each other when it comes to your bridge design workflows. So thank you for answering that poll, and thanks, Anel. So just a quick recap on our civil structure series. So as I mentioned, there was 3 parts to it. So basically there was part 1 in the beginning of the year that my lovely colleague Mapari hosted, which mainly focused on the preliminary design for your infrastructure projects. And she mainly looked at how you will start off in Infraworks and how nicely Infraworks integrated with Civil 3D. So if you are interested in that, we do record all our webinars. My colleagues will drop a link in the chat to that webinar, so you can go have a look at it. Then I think it was June, July, we had part 2, which basically discussed designing roads the easy way. So that's where I took you guys basically through from the model that we used that Mapari created in Infraworks to create our roads and do our final design of our roads now within Civil 3D. But if you guys did join part 2, you would have noticed we ended where we pushed our roads back to Infraworks, and then we said, okay, due to the environment, we actually realized that we need a bridge. So we quickly or briefly started designing our bridge within Infraworks, and that's basically where we are going to start today. So they will share part 1 and part 2 if you want to go look at that. That is on YouTube, so please look for that in the chat. But we are here for part 3 today. So we're going to take off by looking at the bridge design workflow. So with that model we ended in part 2, we are physically now going to design the actual bridge. So that poll that I just launched quickly asked you basically what is the challenges that you are facing. So it's very similar to what you are seeing on the screen now. But as we all know, with any, not even just designing bridges, any infrastructure project or any project you work on, there's a lot of changes that take place. So a big challenge is also managing those design changes, and how are we now going to coordinate all of these changes differently to all the teams and actually keep track of everything that is changing, and how are we going to make sure that all our teams have the right information. And once we have those 3D models and changes, we want to make it easier for ourselves to keep track of the quantities and also make it easy for ourselves to create or calculate the costs. And because of all the design changes, we want to make it easier for ourselves to actually make those changes, and why not automate those changes as well. And then, as you guys mentioned, the most important one to you at the moment, or the biggest challenge you have at the moment, is the lack of integration between the different tools. So at the end of the day, we want a solution that basically allows our different teams and disciplines to work together freely without kicking them out of their design software, for instance. So we want them to be comfortable within their own environment. And at the end of the day, we want to bring everything nicely back together and then share that with the rest of the team. So that's some of the challenges, but what is the actual solution? So one solution that I'm going to show you today, the one we advocate for at Baker Baines, is an Infraworks-Centric workflow. So what I mean by that is Infraworks is going to be at the center, because it's really great for your infrastructure projects where it integrates well with a bunch of the tools within your AEC collection, so such as your Revit and your Civil 3D. It really works well with those tools. So the workflow that I'm going to show you is centered around Infraworks, and what it's going to do is it's going to improve that coordination between the teams, and you're going to see every time there's a design change, you can easily push that back to your Civil 3D environment and your Revit environment as well. And because we are going to have this nice central model, we can also make sure that we have accurate quantities, and the costing is also going to be much easier and reliable as well. So let's first, before we actually jump into the workflow, actually just look behind the workflow, what type of tools we are going to use. So I'm going to focus on the AEC collection. So a lot of you might be familiar with the AEC collection, but it's basically the architecture, engineering, and construction collection. And these tools that you see on the screen, it's basically the tools that are available to you if you were to have an AEC collection. Now, a lot of people think it only has Civil 3D and Revit and Navisworks, for instance, but you can see there on the screen, there's quite a lot of tools that you actually don't know of or maybe aren't using at the moment. So you can see there's Advanced Steel, there's Vehicle Tracking, your Recap Pro, there's even Autodesk Docs as well. So we focused quite a lot on Autodesk Docs in part 2 as well. So if you want to know more about Autodesk Docs, you can jump to part 2. But as you can see there's quite a lot of tools that you can use. So the main ones that I'm going to highlight today to you is Civil 3D, which we basically ended with in part 2, where we designed our roads, we did all our road alignments and corridors and etc. And now we are going to push that back into Infraworks. And within Infraworks, it's a really great tool to start the initial phase or development of your bridge. So the conceptual design of your bridge, it's really a nice actual modeling tool for your structural bridges. And then we are going to push that data back to Revit, because obviously now that we have that structure, we need to actually place it on plans, and we need to generate those sheets with the detailing, the rebar detailing, for instance, and the set out information that will be done within Civil 3D as well. But we also, before we can actually go to site, we need to analyze and design the actual bridge. So that's where structural bridge design, that tool will come in. So we will use that tool to analyze and design the bridge. But then for those who are familiar with, let me just jump back there, are familiar with Dynamo, you will also note that I'm going to show you a bit of Dynamo as well today, because it's really great when it comes to those design changes that I talked about earlier, where with Dynamo, you can actually automate a lot of repetitive tasks that you do. So instead of, let's say, for instance, recreating constantly the bridge, I can actually create a Dynamo workflow that does all of that for me, and I can just run that workflow and it will automatically take place. But I will touch on that a bit later. But this is basically the tools that I'm going to use within the AEC collection. And I just want to highlight something here as well, because I'm going to show you a bit of Autodesk Inventor as well. For those who are familiar with Infraworks and the parts that exist with Infraworks, and what I mean by that is when you actually start modeling your bridge, you will select different parts to model your bridge. For instance, the piers and the girders, it will be a part. But you will sometimes note that the parts that you want to use isn't existing in Infraworks, and you need to create them from scratch, for instance, so that you can have your own custom part. So normally you would use the infrastructure parts editor, which is free to you already. I will show you now quickly where you can find that. So the infrastructure parts editor is basically a parts editor that you will use to edit the existing parts library within Infraworks. And then you can use those parts within your Civil 3D and your Infraworks. So basically it looks something like this, where you can go edit your parts and the existing ones that's already within Infraworks. You can simply find it by going to your Autodesk Manage. It is free to you. If you have an Infraworks license or an AEC collection, you simply just jump to Autodesk Manage. You go click on Infraworks, and you will see, if you go to the extensions, there you can download the infrastructure parts editor. So this is where you will physically go edit those parts that you want to use on your bridge in the future, for instance, if you're not happy with the native parts that exist within Infraworks. And my colleague is also going to share a link with you, which is really nice. They actually did a session at AU where they actually talk about how they use that infrastructure parts editor with Infraworks. But you will see today, I'm going to show you as well, I'm personally not going to use the infrastructure parts editor because I find it's very limited. I would rather create my parts within Inventor. But you are free to go check that one out. It is freely available to you already. And in that AU session, they actually show you the difference if you were to use the infrastructure parts editor and Inventor. So there's no limitations here. It's just if you want to create a custom part from scratch, I would suggest using Inventor. But just to note, this is not part of the AEC collection. It's a subscription on its own. Okay, so the workflow that I'm going to show you guys today is going to include Inventor, but you don't need it. You can always use Infrastructure Parts Editor. Okay. Then I just also want to highlight structural bridge design, the actual structural bridge design tool. So I'm actually guilty of this. I used to do my analysis of my structural bridges or elements in an other third-party tool, or I simply used Robot, but never noticed that there is a structural bridge design tool actually, and it's really great. So when I set up this webinar, I actually realized this is so much easier to design your bridges within the structural bridge design tool. So just to give you an idea of what it can do, it's very good for small to medium span bridges. So when I talk about that, I mean your typical highway or your local road bridges. And I would say it's not really great for massive suspension bridges, but you are free to go try that out. But it's really great for your small to medium span bridges. You can think of bridges up to a few 100 meters long. And then when you do the analysis, it has a load analysis. So you can actually, you can actually analyze it under different types of loads. So for instance, your vehicle loads and your wind loads. And you can design it according to different standards and design codes as well. And the types of analysis that it's used is basically line beam. So you can actually simplify your bridge into a series of beams to quickly calculate those bending moments and the shear forces, for instance. And also with your grillage, you can easily represent your bridge into a deck as of, let's say, a grid of interconnected beams. So it's really good for analyzing your load distribution. And with your frame analysis, it's really great when it comes to understanding the behavior of your elements in 3D as well. So it has a nice view of that. And when it comes to your finite element techniques or analysis as well, you can actually divide your bridge into those 1,000 small elements to look at the stresses and the deflection results as well. So it's really a great tool for a structural engineer when it comes to structural bridge design. Okay. So that's basically a look at the tools, but now let's actually look at the workflow, how we are going to use all those tools together. Okay, so this is the complete bridge design workflow. So all those tools that I just mentioned, you can see here on the screen. So as I mentioned, Infraworks is right at the center because that's the tool that integrates well with the rest of the tools here. And you're going to see now, when I show you the workflow, we don't constantly have to create custom parts, but there is quite a few parts here already that I can start off with my conceptual design phase, for instance, and I can later swap it out as well. But this is the complete workflow. But to explain it better is, for instance, in the conceptual design phase, we will physically look at the road designer and the bridge designer, where they will come in and, like I mentioned in part 2, we had our road designs that were done already, and then we pushed that into Infraworks, and we looked at the environment around our roads, and we noticed that we needed a bridge. So you will start in the conceptual design phase. The actual bridge designer will start modeling that bridge structure within Infraworks, which I'm going to show you now as well. And once that model is done, you can publish that model back to Civil 3D. So we will push that back to Civil 3D so that the road designer can update their road layouts to make sure that it actually do connect to the bridge. And once that has been updated, we simply push back the Civil 3D data back to Infraworks to make sure that the central model is always updated and it has the relevant information. So that's the conceptual design phase. When we look at preliminary design, this is where the bridge designer and the CAD technician will actually sit together and figure out what parts they need to model this bridge before we push it back into Revit and analyzing the bridge in structural bridge design. So what they will do is they will look at if the native parts is sufficient. If it's not, you can always go use the infrastructure parts editor. Like I mentioned, we will share the link with you guys and you can go look at that AU session. It also shows you how easy it is to do it. But from my previous experience, I've noticed it's much easier to do it in Inventor. So I'm going to stick to Inventor. And for those who know Revit quite well as well, you will notice that there's a bunch of families that you can use throughout your project, but sometimes it doesn't have that family that you really want. So instead of creating it from scratch in Revit as well, you can actually use Inventor as well, by the way, to create families for your Revit models as well. So it's up to you guys if you want to use the infrastructure parts editor, but I'm going to show you the workflow using actual Inventor custom parts, because I want to show you how easy it is to create from scratch a great new part that can be used within your structural modeling. So once we have our parts, obviously that will go back to Infraworks. And once we have our final structural model of the actual bridge, we obviously will push that back now to Civil 3D to actually do the grading and make sure we have the correct long sections, and the documents will be started to be produced. And we also will push it back into Revit because we want our structural modelers now to actually start creating the sheets for the actual structural bridge, because we need to obviously also do the rebar detailing for the concrete elements as well. So we will push that back to Revit and Civil 3D, and if changes were to be made within Infraworks, we can always update the Infraworks models in Revit and Civil 3D as well. So that's the detailed design. And then obviously, once we have our documents and all that, we also need to check before we go to site that the actual bridge is the correct size and that it's actually going to stand and it's not going to fall. So what we are going to do is we're going to also take that Infraworks model, and you guys will notice we always keep on grabbing the data from the Infraworks model, because that's going to be your central model. And that's how we will know that everybody is using the correct data. So we will always keep on using the Infraworks model. So that can also be published into the structural bridge design tool. And this is where the bridge engineer will actually run the analysis, all those analysis methods that I shown you earlier, and then he can design the bridge as well. And then he will communicate this back to the rest of the team as well. Maybe there's some changes that need to be made. So basically then the Revit modelers will update their Revit file as well as the Civil 3D modelers, because the Infraworks model will be updated with the latest information coming from the structural engineer who designed the bridge after doing its analysis. And basically this workflow will repeat itself. You might not need to once again create your custom parts. You will simply just adjust the sizes of the girders, for instance, or the piers, for instance. Okay, so that's the actual complete bridge design workflow that I have for you today, but I'm not going to end the webinar there. Obviously, you want to visually see it. So what I've done is I'm going to show you now that workflow that I just explained in action, physically looking at each step now. So conceptual design. So as I mentioned, we will start from Infraworks, do our structural modeling of our bridge, and that will be pushed back to Civil 3D to make sure that the roads line up correctly with the actual bridge. So this is where we will start. So both the road and bridge designers will be working within Infraworks to lay out the initial road layout and bridge structure. So once the extent of that bridge is specified, the initial bridge structure is placed, and now it can actually be interacted with. So for your repetitive tasks, if you don't like manually editing those bridge models, you can actually open a spreadsheet and say, I want the columns to be spaced at this distance, or I want the girders to be spaced at this distance. But as you can see here, you can easily go click on the element and update it as well. So I can easily go click on the girder and I can say, this is actually the section size I would like. And I can also specify the arrangement for the other spans as well, and also specify the cross frame arrangements as well within Infraworks. So once I've done that, I can publish this data back to Civil 3D, so the structural model. And as the road designer continues on with the road, he already has the bridge in his model, and he now can completely finally design his roads. And if there were to be made changes to the structural bridge design, he can simply just update the data set within his Civil 3D model, and he will instantly have that latest model. So there's a nice dynamic link between the Infraworks model and the Civil 3D model. And as you can see, it's very easy to model the structural bridge instead of trying to do that in Revit now without any contextual data. So preliminary design. So we now have our bridge, and we've realized that some of the parts that are used to model our bridge is non-existent. Maybe we want a custom pier, for instance. We don't like the ones that is in Infraworks. So that's where you will use the excuse me, we'll use the infrastructure parts editor, or you will use Inventor now. But I don't want to edit an existing part. I want to create one from scratch. So what I will do is I will simply go to Inventor, and I will decide what is the shape going to be of my pier. So I'm going to have basically 3 different work planes. So I will create my 3 different work planes in Inventor. And on each work plane, I will basically create the cross section of the pier at that work plane. So once I've created it, I can also add dimensions to those cross section, which is really nice. And once that dimensions has been placed, I can make them actually parametric. So I can make them parameters. And if I were to adjust them, the full model will easily update because it's parametric. And I can also decide at the end of the day, what type of parameters do I want to take through to Infraworks. And you will see now that I have my parameters, I can use the 3D geometry tool, which is Loft in this instance. I simply click on the 2 cross sections, and it automatically creates that 3D shape for me. I can add the curves very easily, and this is very difficult, by the way, to do in infrastructure parts editor, but you can see it's very easy here. And I can easily add the chamfers to those sharp corners on the vertical edges as well. And there I'm just simply deciding now what parameters do I also want to push through to my Infraworks. And I simply say export this part now. And you'll see now in Infraworks, I can now instantly use this part. It's now part of my part library. And I can swap the existing piers out with this pier that I just created. And I can copy it to the different locations once again, or I can simply edit that spreadsheet that you saw earlier to say this is the column that needs to be, or pier that needs to be used at all those grid intersections. So it's always fairly easily to create your new part in Inventor, and all those parameters that you have within your Inventor file is also in Infraworks. So I don't necessarily have to come here back to Inventor to adjust the shape or size of my element. I can simply now do that in Infraworks. Okay, but now we need to look at the detailed design of our actual bridge. So this is where the road designer and bridge designer will now finally take that bridge model, and we will publish that bridge data to Revit so that the Revit users can actually look at that data, start creating their sheets and do the rebar detailing, for instance, as well as the road engineers can do the same. They can start doing the grading and all that. So the bridge structure, as I mentioned, in Infraworks can be published quite easily to your Revit at any time. And what it will do is the very first time when you actually open it, it will actually run a category mapping feature. So what it will do is it will ask you this part that was in Infraworks, what do I need to map it to which category within Revit? And when changes do happen again within your Infraworks model, because remember, we always update the Infraworks model, then those changes will be reflected in your Revit as well. And what you can do, if there is changes, you can actually add a note in your Infraworks model and say, this was the changes that were made. And now the rebar modelers can easily add the rebar detailing, they can add the labeling, they can start creating those sheets for their general arrangements, for instance, and the different types of details that they require. And as you saw previously in the conceptual design phase that I showed you, it's also possible to bring the bridge model into your Civil 3D. So here we can do the grading once again, we can create the long sections for our documentation that we require. And once again, if changes were to be made to the Infraworks model, we can simply just update the data set within Civil 3D. So we will always know we are working with the latest information. Okay, so obviously the detailed design phase is going to continue because the structural bridge engineer actually now needs to have a look at the analysis of the bridge, start designing it. Is it going to work? Is it the right size? What is the stresses? So this is basically the workflow. Once again, the structural bridge design engineer won't take the Revit model. He will simply take the Infraworks model because that is the central model that everybody is using, and that's where we all are grabbing our data from. So what's nice is within Infraworks, you can automatically generate your grillage, your finite element analysis models, or even your hybrid analysis models within Infraworks itself. And you will see it starts generating there at the bottom. It tells you how much percentage it's done. So there you can see it quickly. It's not very long. And once that model has been generated, it's now ready to be used within Autodesk Structural Bridge Design for your further development. So once you're in structural bridge design, you can actually, with the automatic loading process, you can start looking at the influence surface generation. So it just does the surface generation for you. And now sorry, my English is running up. The automatic loading optimization can now finally be configured, and you will be able to see the critical loading patterns for the certain relevant areas of the bridge deck. And then obviously, once you have those results, you can look at it visually or numerically. You can generate a report. And once you have that report, you can now start looking at the actual design of your girders, the different, maybe it needs different sizes, or your piers, for instance, and etc. So as you can see, it's fairly easy to use your Infraworks model in the structural bridge design tool. And then once that model has been designed, let's say the girders were to be changed, the size of it, then, or the arrangement of the cross frames, you can easily then adjust that once again in your Infraworks model, the central model, and all the Revit users and Civil 3D users will note that changes have been made because they will get a notification that the Infraworks model have changed, and they can simply update the Infraworks model within their design environment. And we don't have to worry about sharing different files with each other or screaming at each other because my file doesn't work with your file. If we all just stick to Infraworks, everything will work out perfectly. And this is basically what you will end up with a nice Infraworks model. So because it's the central model, we can always then sit with the team, open the Infraworks model, look at it, make sure everything is right before we go to site, because we don't want any clashes or any problems on site. So you can see here, this is really a nice visual representation of your bridge. And we can even show this to the client as well, which is really great. And you can see it's very realistic, which is amazing. I really like it. Okay, but design changes is a big thing, right? So we know that a lot of things change. We don't just stay on one revision of a file. There is maybe 37 revisions across a project, or 500, depending on how big your project is. So we want to make it easy for our teams to update those design changes, or make it easier for them to make those design changes. So this is where Dynamo will come in. So Dynamo is really great because it's basically a tool that helps you to automate repetitive tasks. So this is basically me just adding Dynamo into the workflow as well. So what we are going to do is we can create Dynamo graphs for our Civil 3D environment and Revit environment, and help our design teams to automate those repetitive tasks. So when we, let's say, for instance, have a drastic change on our project, we don't have to panic. We can simply just run the graph, and the design changes will easily be updated on our sheets, for instance. So for those who aren't familiar with Dynamo, this is basically what Dynamo is. So if you were to open Dynamo and create your own graph, this is what you will be seeing. So what I'm showing you basically here is, or rather, let me first explain what Dynamo is. So Dynamo is a visual scripting tool. So when you hear the word script, you might think, oh no, I have to learn coding now. You actually don't need to know anything about coding. What's nice is it has a bunch of preset nodes. So you will see there on your left-hand side, there's a bunch of nodes. And when I talk about nodes, think about within your Civil 3D and Revit, there's a bunch of functions at the top of your ribbon, right? So each of those functions have a node. And you just simply now need to think about your workflow that you want to automate. So let's say, for instance, I want to automate the creation of a surface in Civil 3D. Obviously, first thing we are going to do is we are going to import points. Then we need to tell Civil 3D, but this is the X and this is the Y and this is the Z, for instance. And if you're a perfectionist like me, I also want that points to be on a certain layer. It should also be grouped together. And I want it to be this name, for instance, and this color. And you can think of all the things that you want to change. But then also I need to tell Civil 3D, please create a surface now for me from this point group. And this is what the surface name should be. And this is what the color it should be and the layer it should be on. So basically all those functions that I just mentioned, I just need to go look at those preset nodes, drag them into my Dynamo's model space, and I link those nodes now together in that order the function should play out. And all I do next time when I want to create a surface, I simply run the script and it will create the surface for me automatically. So that's basically what Dynamo is. But that script that I just showed you on the screen is now visually here. You are going to see what it does. So if I were to go to my Dynamo player and I run the script, you're going to see quite easily I can fill out all the information within one place. All it's going to ask me is, what do I want my points group name to be? Should the points be on a certain layer? And then you obviously need to specify what CSV file you want to use. So this script is specifically looking at CSV files. So I simply indicate the file, and I can also now say what layer my surface should be on and what the layer, or rather the name of my surface should be. I just run that script after filling all of that information out in one place, and just like that, I have my surface. So you can think about it. If you have a lot of surfaces that you need to create on your projects and you have all of the survey data, it's probably going to take you about 2 to 5 minutes to create your own surface, putting it on a layer, making sure it's the right color. With this script, within 10 seconds, you have your surface. So it instantly gives you a lot of time saved on your projects. Then this is just a simple example within Revit as well. So if you want to change certain parameter values within your Revit file, so this is just a simple example showing it's looking specifically at the title parameter of my title blocks. So you can see initially it's not capital letters. So I don't want to go to each sheet manually and update the title parameter to be capital letters. What I'm doing with this script is I'm saying, look at the title parameter, please, and make all of them capital letters. Or I could have said, maybe not wanted capital letters, but I want all of these parameters to display this one value. Instead of me manually going to fill it out, you can instantly do that with the script. And then we all know that any infrastructure project has a lot of rebar detailing. So for instance, with your bridges, those piers, if you were detailing those piers and you have all of these rebar that you've done, and the structural engineer now comes to you and say, listen, we are making a drastic change. The size is going to change. The height is changing, everything. You as a Revit modeler are probably going to panic, because he's going to tell you, by the way, we need those latest drawings now within the next hour to go to site. So what this script actually does is you simply specify where do you want rebar. So here I'm specifically saying I want rebar around the openings of this building. It's just a simple example, but you could have in your own script said, I want rebar in this pier. And you will be asked, do you want it to be at a certain spacing? Let's say you want 200 mil spacing, you want Y12s, top and bottom. You can say you want Y16s at the top or Y12s at the bottom. You can think of it. All you do is you just specify that information. You go select the object you want rebar for, and it will instantly create the rebar for you in that object. So you can produce those drawings within the next hour and impress your boss because everything is going to be okay. Okay, so a lot of free scripts that are available to you already. So a lot of people come to me and say, but Nadia, you've shown us these amazing Dynamo scripts, but where do I start? Where do I start learning it? So there's actually quite a lot of free scripts already available to you. If you simply go to your Civil 3D or Revit and you click on the Manage tab, you will see there's a Dynamo player. So with your Revit and Civil 3D installation, you get all of these free samples. So I always say to my clients, go look at the existing scripts that's already there and go edit them to suit your workflow. Don't start from scratch. Use the ones that is already there and available to you for free. And then I have more great news for you guys. We actually have a transformation tools website where we have a lot of free content that you can download. There is also paid for content because we do put a lot of effort in it to create those tools, but there's a lot of free content for you guys to go look at. So you can find that at tools.bakerbains.com. And on the right-hand side, I'm actually showing you one now that is for free to you already. You can scan that QR code and it will take you directly to that ebook. But it's basically an ebook that I created that shows you 10 practical uses why you should use Dynamo in your Revit and Civil 3D. And what I've done is I actually took a snapshot of the actual graph, the actual Dynamo workflow, like I've shown you before when I talked about creating the surface. And I give you an idea of what you are actually doing with this Dynamo graph now. So that one is for free to you guys. You can go look. I zoomed in quite a lot into the actual graph so you can easily see the order of the nodes and what nodes I actually used. And a lot of those are free to you already within your Autodesk installation. So please go have a look at this ebook. It's really a great one and it's for free. Okay, so we talked about challenges, we talked about solutions, and I hope that you guys have some ideas now and are excited for your bridge workflows going forward. As you saw, Infraworks is really a great way to make it the center of your project because you saw now it integrates really great with the different tools. And as we saw in the poll earlier, you guys said it's really difficult to work on projects because the integration between different tools is a very difficult thing. So if we keep Infraworks at the center, everything will run smoothly across the different teams and disciplines. And you saw as well, if I were to update a column or a pier within my Infraworks model, it automatically adjusted the rest of the elements or the parts within my Infraworks model. So it's very easy to iterate the different designs, and also the update of the model can easily be published to Revit and Civil 3D. And it's really nice to bring everything back together to that central model again once changes were made. And we know now that we have a nice central model where we can create costs from because the quantities will be accurate and we can be confident that it is correct. And then lastly, from me, my last poll, I am going to ask Anal to launch the last poll. And what we are going to ask you is basically, what would you guys like us to cover in a future webinar? Because we have a bunch of ideas, but it might not be relevant to you. So we would like to ask you, what do you want to see? So do you want to see maybe more advanced workflows in Revit and Civil 3D, or do you want to have a deeper look at the structural design of the bridges, obviously the structural bridge design tool then, or are you more interested in how Infraworks works with Inventor, for instance, or how the generative design in Infraworks works? But as I mentioned, you guys have also your own ideas of what you want to see. So please, if the ones that you want to see is not listed there, just simply put them in the chat and we will definitely look at that when we host the next webinar. So as Baker Bands, how can we help you? So our slogan here is we like to solve our customers' problems through digital transformation, helping them to design and make a better world. So hopefully with this bridge design workflow that I've shown you guys today, I made your world a bit better. So you can also partner with us or get in contact with us so that we can do a needs analysis for you to help you determine the right mix of subscriptions for your project needs, because you might have different projects that you are working on, not just bridge projects, and you don't have an idea of what you should use within the AEC collection, or is it even relevant to your team. You can just get in contact with us and we will do a scoping session with you and sit with you and actually help you to determine what do you need within your company to better create your projects going forward. And as I mentioned before, we also do training, so it can be organization wide. It can also be project based as well, so we can assist you with your actual projects as well and guide you on the right workflows, as I just mentioned, and then as well as with implementation and configuration. So I did cover quite a lot of docs and BIM Collaborate Pro in part 2. If you guys are, for instance, interested in that and you need help with your Autodesk Construction Cloud setup or templates or project configuration, you can also get in contact with us and we will assist you with that and guide you on the best practices going forward. And enough from me. I'm going to open the floor now to any questions that you might have. Is there any questions in the chat box that I maybe missed?
No, there are no questions, Nadia. But Shakira says hi. She has problems with coordinated Revit models.
So Shakira, you can definitely get in contact with me. So whilst I'm waiting for all the questions, I'm just going to put this slide up. So you can definitely get in touch with me. You will see there's my email address at the bottom of the page. So you can freely email me at nadia@bakerbains.com and I can jump on a Teams call and assist you with that. I see Roberto has a question. Roberto, let me just see. So just to confirm from my team, did I miss any questions from my side? I'm not seeing anything at the moment. Thank you, Shakira.
No, Nadia, no questions from anyone.
Awesome. So maybe I did something right and shown you the best workflow ever for bridge designs, and you're very happy, which I hope you are. But thank you guys, thank you for sticking till the end with me, and I really hope that you enjoyed it. If you want to get in contact with me, nadia@bakerbains.com, and thank you for joining.
Before
Nadia,
you
Have a
leave,
lovely weekend.
Nadia,
Yes,
there is a question.
Mark.
Pranal Naika,
Yes.
she has a question for you. She says, when creating families, example, the columns, can you create it in Revit and take it through to Infraworks?
So, hi, Pranal. So there is a workaround which I will get in contact with you, but I do find it's easier to create the family or rather part in Inventor, because what you're going to do if you try to import a part into Infraworks, a family, for instance, it's going to pick it up as a model. So it won't be a parametric family. So in that case, I would rather use Inventor or the actual infrastructure parts editor. But Pranal, if you have a specific column that you are trying to, let's say you have one in Revit that you want to use within your Infraworks model, just share it with me and I will see what we can do within the infrastructure parts editor for you. But at the moment, I know that Revit families don't integrate well with Infraworks. You can only take a full Revit model to Infraworks. I hope that makes sense. Awesome. Thanks, Pranal. Okay, thank you, everyone. Have a lovely weekend. Bye.